Cook was a captain of the powder days, when captains, you might have said, if you had been fixed by their glittering stare, half down the side, or gaping at them up companionways, were more like warlocks than a humble man. And men were humble then who gazed at them, poor horn-eyed sailors, bullied by devil's fists of wind or water, or the want of both, childlike and trusting, filled with eager trust. Cook was a captain of the sailing days. Those captains drove their ships by their own blood, no laws of schoolbook steam, till yards were sprung and masts went overboard. Demons in periwigs doling magic out, who read fair alphabets in stars where humbler men found but a mess of sparks. That was the captain Cook was when he came to the coral sea and chose a passage into the dark. So Cook made choice, over the brink, into the devil's mouth, with 4 months' food and sailors wild with dreams of English beer, the smoking barns of home. So Cook made choice. So Cook sailed west about. So men write poems in Australia.
In 1770, Captain James Cook, Royal Navy, took formal possession of Eastern Australia for God, King, and England. In 1770, Captain Cook sailed northwards up the eastern coast of what was then New Holland, now Australia. The waters of the Queensland coast were charted by Cook in 1770 in His Majesty's bark Endeavour. Sailed northwards up the sheltered seaway between 15 and 70 miles wide, studded with islands and coral cays, and bounded at its eastern edge by 1,200 miles of coral banks, the Barrier Reef. The Great Barrier Reef, from Gladstone on the Queensland mainland, almost to the coast of New Guinea. The Barrier Reef, 80,000 square miles of coral, as big as England, Ireland, and Wales together. Living coral on limestone banks up to 40 miles wide, growing hundreds of feet from the bottom of the sea.
I'm Peter Woodhead. I'm the Scientific Director of the Heron Island Research Station. The station is operated by the Great Barrier Reef Committee and provides accommodation and scientific facilities at cost for scientists conducting research on the reef. Unlike most inhabited barrier reef islands, which are land islands, Heron is composed purely of coral sands derived from the reef on which the island stands. The research station is therefore uniquely situated right on a fully developed coral reef in clear oceanic waters and with a specialized type of vegetation. For these reasons, it is ideal for the study of turtles, fishes, corals and other marine life, and the thousands of seabirds which nest here.
Demogratta sacra, the white reef heron, a nest of sticks on rocks or in a bush for gentle chicks. The white reef heron, Demogratta sacra, lays 2 or 3 white eggs. The white reef heron stalks among the low-tide coral searching for seafood. 2 or 3 white eggs are laid. The white-capped noddy, Anous minutus, lays 1 egg. It nests in trees up to 50 feet. The nest is flat, of leaves and seaweed glued with droppings. The white-capped noddy lays one egg which hatches in 5 weeks. It eats small fishes from the open seas beyond the reefs, lives in large colonies. The noddy shows so little fear of man that sailors called it noddy, simpleton or sleepyhead in olden English. The common noddy, Anous stolidus, nests on the ground or in a bush. The mutton-bird or wedge-tailed shearwater, Puffinus pacificus, breeds in November on the Barrier Reef, lays one large egg and feeds on small fish. The mutton-bird, Puffinus pacificus, nests in burrows. While breeding, one bird stays in the burrow all day while its mate ranges the sea for food. From March to April, the mutton-bird leaves Heron Island, disperses eastwards over the ocean, leaving its young to follow later. The birds return in late October. The mutton-bird, or wedge-tailed shearwater, nests in burrows. By day, the rookery is silent. The night air listens to thousands of birds. The scrub turkey builds a mound some 12 feet through and 4 feet high of soil and rotting vegetation, eats insects, seeds, lays single eggs.
My name's Frank Talbot. I'm the director of the Australian Museum in Sydney. I'm interested in the biological problems of coral reefs, how they grew in the past, and how they developed such enormous numbers of plants and animals living so close together. In one rock pool, for example, only 50 yards across and 5 feet deep, we found 103 different species of fishes. The fish fauna of a single coral reef may be 2 or 3 times the size of the total fish fauna of New Zealand. Currently, I'm studying the food relationships of these plants and animals living underwater off Heron Island. We use squares to map the types of coral living in different areas of the sea bottom. Fish are closely related to types of seabed over and in which they live. Fish may feed on an organism living in a particular type of coral, or may require a certain sort of sea bottom for shelter or camouflage from predators. Coral reefs thrive in areas of strong waves, waves that can toss around the huge 6-foot square blocks of concrete weighing several tons, of which breakwaters are built. Yet the tiny living coral polyp is able to withstand this wave action and form round itself the hard skeleton which we call coral. By marking out big squares on the seabed with wires, we are able to estimate the populations of the various species of fish in one particular area. Several of us swim over the marked area, independently counting numbers of species. Dr. McMichael is studying the growth rate of the giant clam. Specimens are removed from the sea and taken to the base camp of the research team. A clam is then measured, numbered, and returned to the same spot on the seabed to be remeasured every few years. To investigate their eating habits, I identify fishes collected in reef waters and examine their stomach contents. This information is noted on punch cards for later analysis. Station number 6, Peter. Abidephta saxatilis, 52 grams weight, female. The hugeness of the reef, the incredible variety of its life, and the complex patterns of interaction of the species have provided us with a program for years of continuing research.
Growth and decay, life and death, eat and be eaten, food chains. Tiny drifting plants on the surface of the sea, minute vegetables, diatoms. Eaten by plankton, a floating, drifting assemblage of plants and animals, diatoms, worms, crustacean larvae of slaters, krills, shrimps, crabs, crayfish, the purple pelagic snail Janthena, heteropods, pteropods, ostracods, euphasids, plankton. Sardines eat plankton, swimming among them, mouths open, feeding. Barracuda, long flat teeth slicing and chopping. The sea perch, feeding by night, resting by day. Sea perch eat sardines. Rainbow runners, predators on smaller fish. Rainbow runners eat sardines. Food chains. Shark, in feeding frenzy, will fight, attack, even if injured. Sharks are the scavengers of the reef. Plants to plankton to sardines to sea perch to sharks. Food chains lock and interact to form food webs. Growth and decay. Millions of polyps form a calcium skeleton round their soft bodies, coral. During the night, the millions of polyps in each of the holes of the coral expand and push out their tentacles, starting to feed on the living plankton adrift in the sea. Decay and growth. With the polyps alive, the coral is colourful, turns brittle and white when the polyps die. Green single-celled plants called zooxanthellae live inside the flesh of the coral. They seem involved in feeding the coral. Without them, the polyp is unable to form an outside calcium skeleton. Decay as the tropical waters wash away the limestone base while the polyps build new coral near the surface. As the countless lagoons inside the reef are ever widened and eroded away, the strong reef crests grow outwards, an inch a year. The reef was formed in the Pleistocene age from nothing in 1,000,000 years to 1,200 miles, 40 miles wide of coral banks up the Queensland coast. In 1,000,000 years of growth and decay. When climatic conditions, water temperature, rough wave action, food-bearing currents become unfavourable, decay forces win and the reefs may dwindle. Growth and decay. The tube worm builds a firm, smooth shell and breathes through spiral branched tentacles, withdraws at sign of danger. Delicate hydroid, minute coiled spring, barb and poison. Hydroid coral, bunches of stinging cells it can eject rapidly. The feather star comes out at night, strains plankton from the water. The clam, the largest shellfish, 3 feet long, weighing hundreds of pounds. Clams do not catch people, but filter plankton from the sea, sucking in water and blowing it out. The slate pencil sea urchin, thick, blunt armament of spines. The egg cowrie, covered at night by its black mantle. The mantle opens when touched or moved. Coral feeding, polyps, tentacles extended. Stag's horn coral, Acropora, abundant on the Barrier Reef, providing shelter for smaller fishes. A mushroom coral, the skeleton of a single polyp. A platform coral, a violent storm may break the platform off its stem and turn it over. Large, stony, rounded brain coral. Soft corals also have a skeleton. Unlike the hard coral's rigid calcium, a flexible structure of spicules interlinking and overlapping around the tiny coral polyps. Spicules form distinctive shapes, the many soft corals of the Barrier Reef. The strange long-snouted wrasse gomphosis eats tiny creatures from the cavities of the coral. A yellow-tailed wrasse and algae-eating drummers. The Moorish idol swimming among drummers and unicorn fish. Diploprion or yellow emperor. Sea perchers will eat what they are able to catch: shrimps, small fish, mollusks, crabs. The sea perch does not sleep, but rests by day in lazy schooling and hunts by night in ones and twos. The adult damsel protects its young, shepherds them into the coral at night and watches over them during the day. The wide-striped bullfish hides in coral if attacked. Sweetlips with a cleaner fish. A cleaner fish eats parasites growing on a larger fish and keeps it clean. A large fish will not harm a cleaner. The angelfish, a vegetable feeder with long sharp cheek spines for protection. The striped toby, poisonous if eaten. Predators recognize its colouring. The weaver fish lives in a sand burrow, it digs itself. The anemone fish lives unharmed in the stinging tentacles of the anemones, thus protected from larger fish. The trumpet fish swims alongside a vegetable feeder, using it as camouflage. A small fish will be pounced on by the hidden trumpet. A butterfly fish. 30 species on the Barrier Reef. A butterfly fish. A vegetable feeder. Small bristled teeth for scraping algae from the coral. A butterfly fish with false black eyes to confuse and frighten bigger fish. A butterfly fish in nocturnal colouring. By day this fish has no white spots. A netted leather jacket, poisonous to eat, stands upright in weed to escape detection. As night falls on the Barrier Reef, a sudden change, as some fish feed and some fish sleep. A tiny fish sleeps in coral, magnified here 1,000 times.
I'm Robert Bustard and I'm a zoologist at the Australian National University. My interest is in the behaviour of sea turtles and the natural regulation of their numbers. Between November and March each year, I come up here to the Heron Island Research Station to conduct fieldwork. Female turtles of the green and loggerhead species nest here during the summer months. To find out at what age turtle hatchlings breed for the first time and how many survive, we began a hatchery to enable us to tag them. Later, we note the tags on nesting adults. My research is part of a 20-year program. Heron Island is small enough for 3 trained observers to collect data on every turtle that comes ashore to lay. We patrol the island each night at high tide when the turtles come ashore, observing and tagging the nesting females.
To return here from 1,000 miles away after 3 years. At night to climb out of the high water up into the dry, rough coral sand. to make a foot-deep sandy pit for 250 pounds of mother turtle to lay 110 eggs. Pushing up and stretching down into the damp sand below, only to try again and try elsewhere until dawn if tree roots and crumbling sand, to make a place for 110 eggs before morning, or else to have to try again tomorrow night, until the stretching flipper reaches only air. Then to protect the nest with flippers curled behind and lay first by ones and then by twos, then threes and fours, to lay in 15 minutes a clutch, 110 eggs. And of each 1,000, one will live to mate perhaps in 7 years. To break the shell and lie 2 days absorbing in itself its umbilicus by which it lives, not eating. And then to push up with its 100 brothers all together through the sand. And lie heads poking through away from burning sun and hungry sharp-eyed birds until the night. When top ones struggle forth, those lower pushing up beneath them through the sand, and rush pursued by ghost crabs down towards the lightest horizon, the sea, and swim into the waves beset by fish and sharks out to deep water, where swimming near the surface are not seen by birds, black shells against black sea, by fish, white undersides against white sky. To be unknown till of their 1,000 one shall mate in 7 years, and gently fill the hole with sand, then push it hard, the stickiness on the eggs holding the sand from crushing them. To dig a false nest, 5 yards more, another hour, 1.5 tons of sand later, to lead the hungry dog and greedy man away. And pushing down the beach, excreting sea salt from both eyes, back to the tropical sea. The sea. The life environment of the Barrier Reef, the reservoir of its continued living, from which the turtle comes to lay every 15 days 5 times this summer, and then at the same place lay again 3 years later, to which her young will go, where life continues, evolution of new forms, new species. Unless man kills and eats, unthinking, wasteful, unless the spreading poison filth of cities, mass production, radiation.